Hello and welcome back to Ganesh Institute. So in today's video, we are taking up another topic from linear algebra, which is eigenvalues. Now you might, I have already made so many videos on eigenvalues and vectors. Then why this up? So I want to tell you one trick to find out eigenvalues when it is very difficult to solve the cubic polynomial. And that is with the help of trace of a matrix. So, are you excited? Let's get started. So, let's take up this example is this matrix of order 3 by 3, and obviously you are supposed to find out the eigenvalues of the matrix, okay? So, usually what we do, we have to firstly create a characteristic polynomial, right? And the value of this can be found out using a minus lambda I, and this is the matrix, right? When you put a minus lambda I determinant as 0, this becomes characteristic equation. And with the help of that equation, we find out the value of lambda, that is eigenvalues. Because it is of 3 by 3 order, so there will be 3 eigenvalues. Okay, let's get started. So a minus lambda I, that means 1 minus lambda, minus 2 minus lambda, and minus 3 minus lambda, correct? Because a is this 1, 1, 2, 1 minus 2, 5, 2, 5 minus 3, right? And when you subtract lambda I is 1, 1, 1. This is the identity matrix of 3 by 3 order. When you multiply it with lambda times 1 will give you lambda, and rest all other elements will be 0. So this is how, if you subtract this now, so 1 minus lambda will give you 1 minus lambda, minus 2 minus lambda, and then minus 3 minus lambda, correct? Rest all will remain the elements of A matrix only. So let's write down all these elements which are non-diagonal elements. Okay, I mean off diagonal is this one, and this is principal diagonal, rest all other elements. So this is the matrix. Now you have to take the determinant of this matrix, right? So when you take up this matrix and its determinant, you have to keep it 0. Now what you are supposed to do, create an equation. Okay, so 1 minus lambda, first row first column, you have to hide these things and multiply these two. So this will be minus 2 minus lambda multiply minus 3 minus lambda minus, so minus 5 5 is a 25, correct? Minus second element, then hide the rows and columns and rows of that particular element, and then find out the matrix, the determinant, minus 3 minus lambda minus 5 times 2 is 10, then plus 2. I hide this row and this element having 2 as its common element. Now 5 is a 5 minus, when you do minus, okay, let's do it step by step. So minus 2 and minus 2 minus lambda. Just hold on. This pen is okay. Now, if you solve it further, so 1 minus lambda minus 2 multiply minus 3 is 6. Minus 2 minus lambda is plus 2 lambda. Minus lambda minus 3 is plus 3 lambda. Minus minus plus lambda squared minus 25. Minus, if you see this, this is minus 13 minus lambda. So this will become plus 13 plus lambda, correct? After multiplying it with minus 1. Then if you see, this is 2, then 5 minus minus plus 2 to the 4 minus minus plus 2 lambda, right? So 1 minus lambda, I should change the color, okay. Then 6 minus 25, 15 minus 6 is 9, so minus 19, 2 and 3 5 lambda plus lambda square, and here 13 plus lambda, then plus 2. 5 minus 4 is 1. So 2 ones are 2 plus 2 to the 4 lambda. Correct? Now, if you multiply 1 minus lambda with this, it will give you what? Okay, firstly multiply it with 1. So 1 will give you minus 19 plus 5 lambda plus lambda square. Then minus lambda will give you minus minus plus 19 lambda minus 5 lambda square minus 5 lambda square and then minus lambda cube. Correct? Rest 13 and 2, 15. Then lambda and 4 lambda, 5 lambda. Correct? So if I simplify it more, so highest degree minus lambda cube, then minus 5 plus 1 minus 4 lambda square, then 5 and 19. This is 19, right? 19, 5, 24 and 5, 29 lambda, and then minus 19 plus 15 is minus 4. Hold on, this is minus 19, right? And this is plus 15. So this is the equation. Let's recap once. So this is 1 minus lambda, 6 plus 2 lambda, 3 lambda, lambda square minus 25, minus 1, 3 minus lambda minus 10, plus 2, 5. 5 minus minus is plus 4. So 5 and 4, 9. 9 twos are 18 should be here. So when 18 is here, 18 and 13 will become 31. Right? So this will be 31. So this is not 15, this is 31. Correct? Now 31 minus 19 is 12. So this is our characteristic equation. Okay, now we have to solve this. So let's see. I'm writing it down here. The equation is lambda cube plus 4 lambda square minus 29 lambda minus 12 equals 0. So usually what we do, it is a cubic polynomial or equation. So it will be having 3 roots, 3 eigenvalues. So first, let's try hit and trial. If I put 1, so 1 cube is 1, 4 ones are 4, minus 29, minus 12. This is 42, 9, 10, 11. So 41 and 5. No, it is not giving 0. So you will be keep trying and you will see that okay, plus 1 is not working, minus 1 is not working, plus 2, plus 3, minus 2, minus 3 is not working. These values are not working. So how do you want to waste your time in doing this one question, though you know that you know it very well? So for that, you can use the concept of trace. What is trace? Trace is basically sum of the principal diagonal value. Okay? It is the sum of principal diagonal value, and also it is equal to sum of eigenvalues. This is one topic which you can use. Also, other thing is, always remember, if you see that the matrix which is given to you, let me write it down. So this is the matrix which is given to you. If you observe that all the 2 is 4, 1 and 5, 6 minus 2, 4, 5, 7 minus 3 is 4. If the sum of each row is same, that means that equal value is one of the eigenvalues. Interesting, no? So if you find, remember this is only for that matrix where sum of each row is equal. So now you have got one value of lambda. This is what you required. So that means lambda is equals to 4 will give you lambda minus 4 as one of its factor. Now you can find out rest 2. How? By using long division method. So lambda is here, lambda square. So lambda cube minus 4 lambda square. You can change the signs. 4 and 4, 8 lambda square minus 29 lambda. This is 8 lambda Now 8 lambda square, just bear with me. 8 lambda square minus 32 lambda minus plus minus. So 8 4s are 32, that's why. And then 32 minus 9, 12 minus 9 is 3, right? 3 lambda minus 12, that means plus 3. So 3 lambda minus 12. So the splitting of this gives you lambda minus 4 and lambda square plus 8 lambda plus 3. Now again, this is very hard to solve by middle term splitting. In fact, you cannot do it. So let's apply quadratic formula. D discriminant is equals to b square. This is a1, b8 and c3 here. Correct? Coefficient of the values and c is constant. Now discriminant is b square minus 4ac. So 8 square minus 4ac, 64 minus 12. What it gives you? 4 minus 2 is 52, and we can write it 13 times 4. Now lambda will be minus b plus minus root d upon 2a, right? This is the quadratic formula. So minus b is minus a plus minus root d. If you take the root of this value 4 there, then 2 into a 1, you can divide the numerator by 2. You will get minus 4 plus minus root 3. So these are two eigenvalues. Minus 4 plus root 13, minus 4 minus root 13, and this one 4. I'm hoping that you got this topic very well, that sum of each row, if that is equal, then that equal value is the eigenvalue of the matrix. Thanks so much for watching this video. Take care of yourself.